Hello everyone, welcome back to this Agentic AI series, and in the previous video we learned about how we can implement the LLM models, and before that we learned about the LLM architecture. So till now we covered the LLM models. Now we are going for the next topic, that is a RAG, and this RAG full form is Retrieval Augmented Generation. Okay, so for now, as we already know, our models are trained on the large training data sets, and they'll refer this training data to give us the information, or they'll generate the output according to that training data. So LLMs are already trained on these large data sets with the help of any journals or publicly available information or any books like this, right? So however, this knowledge is static, right, and limited to the data available during the trainings. Whatever the data is till the training time, suppose today if we train that LLM model till the today's date, whatever the information is there, we are just training that models to that information, and after 1 year if we'll go and see, there are so many changes, right, within the 1 year, but LLM is not trained on that data. So they just have one static data till today's date. After between 1 year what happened, they don't know about these things, right? So that's why we are saying it is a static and limited data for the LLM models. So now what we want is, we want this LLM to understand the private data and public data as well. If we are saying private and public data, what we mean is, so if we'll talk about the private data, so companies will have their specific data or their own data. So they'll have DBs, confluences, Jira, code bases and all, right? So they will not expose this data to the outside world. They are their information, so they'll be keeping it with them. So these are the private data. If we'll talk about the public data, any news article, blogs, documentation or web pages or any public content, right? So that will be generating every day, right? These blocks will be coming maybe monthly or daily basis like this, but that LLM is not trained till that time. So we train till today. After today's date, whatever the data will be coming in the market, they are not aware about these parts. Okay, so that's why we are going to use the RAG concept here. So RAG is an architecture that enables model to retrieve external knowledge base from a knowledge base and use it during response generation. So if we'll take example, what is leave policy of my company? If we'll go and ask to the LLM, what they'll do is, they trained on a general data, so they'll go and check their training data, and they'll give us the responses for that, and the answers will be the generic answers, and we don't want it because we want our company's specific data. So one way to solve this, what we can do is, with this we know what are the policies are there, right? So we can provide that policy data with our prompt, like, what is leave policy of my company, can you read this PDF and get the answer for me? So it will go and read that PDF as well, and at the end we'll be getting the response, what are our company policies are there. We'll get that data from the LLM, but this document will be large document, and that is a document for our company. We cannot expose it to the general LLMs. So that is also the one case, we cannot expose that data to the LLMs, and that document is also a large document. If it's possible, we'll provide that data to the LLMs. That is a huge file. Okay, we'll have so many policies over there, so that will be a large document, and it will increase our token cost and uses, and that is not efficient as well, because our token cost will increase, and if token cost will increase, we have to pay more. So that's why this is not the efficient approach. So that therefore we are going to use the RAG concepts here. Okay, so what RAG will do is, RAG system, what they'll do is, they'll query a knowledge base and add a more context to that. So if we'll say knowledge means here is any company specific DB, their code bases or their Jira or Confluences, they are the knowledge base, okay, for the RAG systems. And If we'll talk about the public data, they'll have some documentation, news article. These are the public data, or we can say these are the knowledge bases for the RAG. So what this RAG will do, if we'll see here, so if we'll put some query or we'll be giving some questions, okay, so this what it will do is we'll ask some questions. If we'll not provide any, this is the generic LLM models, what they'll do is, they are the standard LLMs, they'll have some generic answers with them. They'll provide that wrong answers, generic or wrong answer, whatever we can mention it here, and then it will give us the manual context injection. Okay, so manually it will now manually we are going to inject it, because we already know this is a standard LLM. It can give us a generic information or a wrong information which we do not need it. So now what we are doing is we are adding a manual context here. So we'll be additionally we are adding our PDFs over here, and then we'll have our user query, then we'll have our context also, and then it will get the answer. But here the issue is we will have the high token cost. So tokens cost is getting increased. This is the generic LLM, what generic LLM will do. But if we'll add RAG here, in place of just a generic LLM, we'll add the RAG. What will happen is, this is the optimized way, this is the optimized way. So this high token cost issue got resolved now. So what it will do is, it will do the retrieval means it will go to the company policy page and it will retrieve that data, and whatever data, that data it will divide into the context. We'll see all these things. Okay, it will divide that data into the context, and that contextual data plus the prompt what we are asking, right, that will go to the LLM. So now LLM have all the context, right, that's why it's mentioned here contextual LLM, and at the end it will be generating the accurate and cost effective response for us, because now it have that policy information, whatever the company policy is there, it have that information as well. And we are not giving complete file, so it will not go and read the complete file here. So that's how it's cost effective. And this is the vector DB. Vector DB means we'll have that company policy information in this DB. So this RAG will do retrieve that data from the vector DB and then add the contextual data with to the LLM, and we'll get the accurate and cost effective responses here. Okay, so this is divided into the three parts. One is retrieval, then augmentation, and then generation. Retrieval means we are going to retrieve the data from the internal sources, just like as a company policy or any public resources, just like as any blogs or any articles. When we'll talk about the augmented means we are augmenting the prompt with the retrieved information. Whatever information we retrieved from this retrieval part, we are going to augment that information with our prompt here. Okay, and then generation, this part LLM will generate the responses whatever based on the augmentation, means whatever information we provided during the augmentation process, according to that they are going to generate the responses for us. Okay, and now what RAG will do here, okay, why we implemented this RAG here. Okay, so RAG will allows the system, it's allowing that our system to go and use the external knowledge bases, just like as company data or any specialized data sets or public data sets. According to our implementation, it will allow us to retrieve that relevant information based on our query, and then LLM will have that context and our prompt, and then it will produce the accurate and context specific answer. And this will get from the research paper that is published by the Facebook. Okay, so from this research paper we got to know about these RAG concepts. So this paper describes RAG as a general purpose fine tuning recipe. Okay, because it means to connect any LLM with any external or internal resources. So fine tuning recipe means we can fine tune means for these LLMs, these datas are trained on a general purpose, but if we want to train them is to the specific part, or just we want to train them for the computer science, we can fine tune it. If we want to know that models for our company specific data. According to that we can fine tune it, right? So with any external or internal resources we can connect that LLM. That's why they mention it as a fine tuning recipe. Okay, now how does this RAG works here? So what we already know, if we'll give the query, it will go to the knowledge base and add the relevant context to the prompts, user prompts, and before generating a response, and after that it will go to the LLM and LLM will generate our response, because it now it have company specific data as well, or any data which we want to retrieve, right? That is specific data it has, and prompt also, so it can give us a proper response now. Okay, so for this we are following the 5 steps. Okay, we'll see it one by one here. Okay, as a user what we'll do is we'll send a query. This is the first step, we are sending a query. Inside this we'll have retrieval augmentation generation process. Okay, so now these steps will start one by one. First, what retrieval, we'll have one retrieval system. What it will do is it will search the knowledge base. Okay, so whatever knowledge base, in knowledge base whatever data we feed it will go and search that knowledge base, and it will return the relevant documents. Okay, just like as we asked, right, what is the leave policy of my company? So this knowledge base have my company policy document, and this retrieval system went and searched for that company policy page, and then it's returning the relevant document to the retrieval system. When we'll have that document, then this is the relevant data which will go to the prompt augmenter. What it will do is will have now relevant data. Okay, that policy leave policy plan it has. Okay, now that original prompt, originally what we asked, that prompt plus this context, it will go to the large language models. Okay, so now augmentation part is done. Now here we augmented that data to the and augmented it and passed to the large language models, and then what large language models will do, they'll generate the responses for us. Okay, whatever the context and prompt is there, according to that they will generate the responses. Okay, it will go to the output generator, and then final answer it will go to the user, so user will get the final answers from that. Okay, benefits now. So cost effective AI implementation and AI scaling. So RAG is more cost efficient. If we'll see, right, before what the LLM is doing, we have to provide the complete PDF. Maybe that PDF is for 50 pages. So the token cost will increase, but now we are not providing the complete PDF over there. So RAG is more cost efficient than sending full document in every request. What we are doing is here we'll retrieve whatever the relevant data is there from that PDF. We are retrieving that data, so it will reduce that token cost, and after that it is like fine tuning. We are fine tuning that data. What are the relevant data is there, we are just getting that data. So here the RAG will not do not need any retraining. We do not need to retrain that RAG models over there. Okay, when any data will be changes, we are simply updating that DBs, our knowledge bases. So we that RAG will not need any retraining over here, just like as LLMs. Okay, then access to current and domain specific data. So they have access to the up-to-date data, because we are updating that data to the knowledge bases, so they have access to the current or recently data, and they knows, okay, that if company have that knowledge base, it means company specific data is there, so it will be easy to retrieve that information from that any external or internal knowledge sources, and this will overcome that knowledge cutoff limitations. So just like as how LLM was trained, and in future they don't know what is the recent updates, but that RAG system they'll not do it. Okay, so LLMs, what it will do, LLMs by retrieving the latest information from external data sources now. So LLM is also retrieving the information from the external data source with the help of RAG. Now lower risk of AI hallucination. Why we are saying this? Because we have now factual data. Okay, we have some company data, so that is a factual data, so it will not it's not completely eliminating it, but still that hallucination will not be there, because we can go and verify data. So it have some specific data, and according to that we are getting that responses, so that hallucination will reduce here. So after that we'll have increased user trust. Okay, so that is that source already I have. If I go to the my company policy and I can re-verify it, okay, what the response from LLM I got it, whether that is correct or not. So it will build us a trust. Okay, I know I checked it last time, that data was correct, so maybe next time also you'll get the correct data. But still 100% we cannot rely on this, because these things are according to the probabilities. Okay, they are not the deterministic ones. Okay, next, what are the use cases? So we'll have specialized chatbot and virtual assistants. So they can power that chatbots and virtual assistants by connecting LLM with the company's specific data. So if any user or any user want it, okay, so they know about the product services, what are all the policies and internal workflows, so they are aware about these things. Okay, so this enables the system to provide a accurate and context aware customer supports. Okay, then next is research work. So we can read internal documents and combine them with the external researches as well. But here what it will help us is, it will summarize that data, it will retrieve that data and analyzing on the large amount of information. If we have hundreds and hundred of pages, it will help us to summarize that data, right? So this will help in the research phase as well. Then content generation, what it will do is, it will go and retrieve the information from the trusted and authoritative sources. So it will improve the reliability or factual accuracy of whatever the content we are going to generate. Then market analysis and product development. Okay, so that business teams, what they'll do is, they'll analyze the market trends, their competitors, what their competitors are doing, what activities they are making in the market, and what are all the customer feedbacks, then news and social media discussion. There are so many things, right? So RAG can help them to get the recent data, so they do not need to go and search all the articles or read that, right? So that RAG will go and do all these stuff. RAG will retrieve that data from the external sources. And here product manager, what they can do is, they can use these insights for future product involvement. So now they can make the decisions. They know, okay, now they can use the RAG. So it will, what it will do is, whatever the information came from the business team, according to that product managers, they can use these things, insights, and they can make their future product improvement. Then knowledge engine means, this will act as an internal knowledge assistant. So for employees, it what it will do is, it will provide a quick access to the company documents, policies, whatever technical guides are there, and their organizational knowledge. So they can get everything in one place. Okay, so that's how it is helping to the engineers as well, or we can mention it as a developers or employees. Okay, it will be helping us to the employees. And we'll see this RAG in depth in the next video as well. Thank you.